Okay, so this goes a lot with what we learned before Thanksgiving break. We were graphing, but now we're graphing inequalities. Okay, so inequalities, the difference is that it uses these symbols instead of an equal sign. Yeah? So we're going to talk about what those symbols mean when we're graphing, and then we'll graph. So first symbol, who knows what that is?
Greater than.
No,
Less than.
less than. Now when we graph this, we use a dashed line. Okay, this is greater than. And we also use a dashed line because they are not equal to, which is why we're using a dashed line. Now, if you hold up your left hand, okay, that's your less than sign. So if you struggle with which is which, if you hold up your left hand and make the L or whatever, that's your less than sign. Okay, the thing to know about less than and greater than are dashed lines. Dashed lines do not hold solutions. So if you have a point on the dashed line and it says, is that a solution? You'll say no, because dashed lines do not hold solutions because they are not equal to. Okay, so this is, whoa, less than or equal to, because it has the line underneath. Okay, we graph that with a solid line because of the equal to. This is greater than or equal to, which is also graphed with a solid line. And solid lines do hold solutions. Now, this is the less than sign, and there's a trick when y is alone. Now, this trick only works when y is alone. So if it's in standard form, this trick does not work. Okay? If y is less, if something's less than you, is that above you or below you? Below, so you shade below. So if y is less than or equal to, you also shade below. Now if something's greater than you, that's above you, so shade above. Y is greater than or equal to, you also shade above. Now this only works when y is alone, when it's in y equals mx plus b form. So these first ones are in y equals mx plus b form. What does m stand for? Slope. And what does b stand for? That's your y-intercept. That's why we call this slope-intercept form, because it gives you your slope and it gives you your intercept. Which is nice because that means you don't have to do any math when you're graphing. So first things first, look at this symbol. Is it going to be a solid line or a dashed line? Dashed, because it's not equal to. It's always good to pay attention to first, because if you're like me, you're going to accidentally do a solid line and then have to erase. Okay, what's my slope here? 3, because it's whatever's touching my x. Now, I always want slope to be a fraction, so I'm going to write it as 3 over 1. which means I'm going to rise 3, right 1 because it's positive, positive. What's my y-intercept? 1. Which if I wrote it as a point, it's going to be 0, 1. So on my y-axis, this is your y, this is your x. I'm going to put a point at positive 1. And I'm going to rise 3. 1, 2, 3, run 1. Now after I rise 3, run 1, I'm going to go down 3, backwards 1. Now on these, you do have to go all the way across your graph. If you only have 2 points or 3 when you could fit way more, I'm going to take off points. Now we said this is a dashed line, so I usually just draw a dash through every dot or connect every other dot, however you want to do it. Now, y is alone, and I have y as what? What symbol is that? Less than. If something's less than you, is that above you or below you? So which side is below my line? To the right side, because if you put your pen on your line and you pull it down because it's below, it's that side. So this is my below. Now it's asking if these are solutions. So if I have -1, -2, is that a solution? No, why not? It's on a dashed line. It is not a solution. Okay, well then I have 3, 1, so over 3, up 1. Is that a solution? Yes, because it's in the shaded area. Shaded area and solid lines hold your solutions. So then I have -2, +2. Is that a solution? No. Now, another way to check these is you could always plug it into your equation. Now, you don't always have to do that, but if it didn't have a graph and it said, are these solutions, this is how you would do it. So we have y is less than 3x plus 1. I just rewrote it. And you would just plug it in. Well, this is my x, this is my y. So y is -2 is less than 3 times -1 plus 1. Well, can I just type that right side of my calculator? Yes. So I have, bless you, 3 times -1 plus 1, and that gives me -2. Is -2 less than -2? No. And that is why the answer was no. Yes? Because that is not true. That's false. Okay. Now you could do that with all the points. We're just going to do one. So if you ever have a problem where it has just the equation, it says, are these solutions? All you have to do is plug them in. Cool? Simple enough? Awesome. Okay, so let's look at the bottom. It says, write the inequality for the graph at the right in slope-intercept form. Well, we know slope-intercept form is y equals mx plus b. So I know I need to find m, and I know I need to find b. I also need to find the symbol. Well, where is it shaded? Is it shaded above or below? Above. And is it a solid line or a dashed line? Dash. So which one has a dashed line and says shade above? Yeah, so we know that this is going to be y is greater than. So now we have to find our slope and our y-intercept. Well, y-intercept is the easiest. Where does it touch the y-axis? 2. So we know that this is going to be a +2. We know we're going to have an x, so the only thing we're missing still is our slope. Well, I see that there's also a pretty point here or here. So if I go down 1, 2, that's a -2, right? And then I go right 1, 2, 3. And right 3 is positive. So this is -2 over 3. So when you're done writing that down, go ahead and flip to the back. So the front is when y is alone. That's your slope-intercept form. What form is the back? Standard form. This is when a and b are on the same side. So things that we need to remember about standard form. Well, how do you find slope from standard form? It's your opposite a over b, opposite a over exact b. Okay, that's something to remember. Also, to find an intercept, remember you just plug in. So for x-intercepts, y is 0, and for y-intercepts, x is 0. So those are the things that you need to remember about standard form. So knowing that, this inequality is written in standard form. We still can tell if it's solid or dashed line. What kind of line is this one going to be? Solid, because it's equal to. However, we need to find an intercept and a slope. Do we have to find both intercepts or just one? Just one. If you find just one intercept and you find the slope, then you're good to go. Okay? So on this one, I'll find x-intercept, and on the second one, we'll find the y-intercept. So to find my x-intercept, that's where y equals 0. I'm going to use this equation, and I'm going to plug in y0 and solve. So 3x minus 2 times 0. And I'm going to use it as an equation. We don't really need the inequality yet. That's not until I'm graphing. Well, what is 2 times 0? 0. So this cancels. And I'm left with just 3x equals 6. And how do I solve that? Divide both sides by 3. And what does x equal? 2. So my x-intercept is 2, or it's 2, 0. So on my x-axis, this is my x-axis, I'm going to find 2, and I'm going to put a point. I do not have to find both my intercepts, so we're going to ignore the y-intercept here. And then I have to find my slope. Well, slope is opposite of a over b. So what is opposite of a? Over exact b. And 2 negatives makes a positive. They cancel each other, the negatives do. So this becomes 3 over 2. Well, positive 3 over 2 tells me I'm going to rise 3, run 2. So from this point, I'm going to rise 1, 2, 3, run 2. And I have to go all the way across my graph, so now I have to do opposite, opposite. So down 3, backwards 2. And we said this is a solid line. Now I'm not done, because I cannot just look at my symbol here and tell you where to shade, because it's in standard form. Remember, we said that only works when y is by itself. Is y by itself? No. So I'm going to rewrite my equation. 3x minus 2y is greater than or equal to 6. And I have to test a point. Well, y'all, the easiest point on your graph to test is 0, 0. However, you cannot pick a dot on the line. So I'm going to pick 0, 0. Okay, now if 0, 0 is on your line, pick something on an axis. So I'll show you both. So if I test 0, 0, and I plug that in, well, x is 0, minus 2 times y is 0, is greater than or equal to 6. What's 3 times 0? Minus 2 times 0. Is 0 greater than or equal to 6? No, so this point is false. So if this side's false, what does this side have to be? Yeah, if one side's false, the other side has to be true, correct? So I am going to test a point. Now, normally you do not have to test more than 1 point. If it's false, the other side's true, end of story. As long as your line's correct. Okay? I am going to show you, though, if 0, 0 is on the line, the best thing to do is pick a point that's on an axis. Doesn't matter which one. So I'm going to pick this point of 4, 0. So I'm going to test the point 4, 0. And I'm going to plug that in. So this is my x, this is my y. So 3 times 4 minus 2 times 0 is greater than or equal to 6. Well, what's 2 times 0? 0. And what's 3 times 4? 12. Is 12 greater than or equal to 6? Therefore, this side is true, and that's why we're shading on the true side. So did we shade above or below? Below. However, if you look at the symbol that was greater than, doesn't greater than tell you to shade above? Do you see why you can't trust the symbol here? Okay. Any questions with that? Okay, so let's do another one. Okay, again, it's in standard form. Is this one going to be a solid line or a dashed line? Okay. And last time we found the x-intercept, so this time we're going to find the y-intercept. Now remember the trick, if one of them is going to give you a decimal, does 2 go into 20? Yes. Does 5 go into 20? Yes. So you can find either one. Doesn't matter. So if we find the y-intercept, that's where x equals 0. Okay, so we have 2 times 0 minus 5y equals negative 20. Well, 2 times 0 is 0. How do I solve that now? What do I do? Divide both sides by negative 5. And I get y equals what? Positive 4, because 2 negatives makes a positive. So my y-intercept is 4. So this time, on my y-axis, I'm going to put a point at 4. Now slope, we do opposite of a over b. So opposite of a is negative 2, exact b is negative 5. 2 negatives makes a positive. So I'm going to rise 2, run 5. And this is a dashed line. So when it's dashed, I draw my dashes through my dots. So is 0, 0 on my line? So is that my easiest point to test? Yes. So I'm going to test 0, 0. So 2 times 0 minus 5 times 0 is less than negative 20. Well, that equals 0. Is 0 less than negative 20? No, this is false. So if this point is false, what's this side? True. Therefore, we're shading above. And we're not going to do example 5 today. That's something we're going to talk about more tomorrow. So one thing I do want to remind you, when you're done writing this down, flip to your practice. Okay, if you look at these, well, first 3, are those done like the front of the notes in slope-intercept form? Y's by itself, those are simple. Yes, there's not really much math you have to do other than graphing. Okay, these 3, well, 2 of them are special cases. Which 2?
The y.
Well, this one has no y, so is that a special case? Do y'all remember the acronym that helps you with that? VUX. This is vertical undefined x equals or inequality equation. So I'm going to be graphing this with a vertical line. Yes? Now, when I think about where to shade, there's no bottom and top, right? So think about your x's. Where is x less than 5? Is it going to be to the left or to the right? Okay, that's what you'll look at. Here, this has no x, so this is a Hoy equation, horizontal zero slope y equals equation. So you're going to draw a horizontal line here and a vertical line here. Yes? This one is not a special case. It has an x and it has a y. What number can I put in front of x that doesn't change anything? 1. Now what can I add to it that doesn't change anything? 0. So what's your y-intercept? 0. And what's your slope? 1, which is 1 over 1, so you're going to rise 1, run 1. Yes? Okay, so this is your practice. If you have questions, let me know. If you want,